Hello and thanks for watching. Please make sure you like and subscribe to this channel. So this video is how to fault find and dismantle a Vaillant Ecofit Pure, Home and Sustain. Also, this is for the Glowworm Energy, Betacom and Ultimate. The resistances are the same, the components are the same. The way you get to the D codes on the Glowworm and the Vaillant is slightly different. I'll leave that up to you. Any questions, please comment. Make sure you like and subscribe to the Warriors of Warmth channel. Please go to the website. If you go to the website, you'll find loads of free training material. On the website is PowerPoints, PDFs. So if you're training, you're at college, or you've got any exams coming or resits, go to the webpage. If you can donate anything to fight the fuel poverty cause and help charities across the UK and spread community spirit, please comment below. Please like and subscribe. Enjoy. So, to drain the boiler down, this is the area here. You can put a hose just over that. So, it's closed. Open it, you feel the resistance. And if you keep going a bit more, you can take the whole thing out in case the O-rings are worn. And this is inside the drain off. 2 O-rings. So when you fit these, when you're working on them, I always recommend fixed head spanners. A fixed head spanner is smaller and tighter, so you can get into all the areas. When you go to fit one of these boilers, what I would recommend is that you tip it upside down and then you make the connections and then hang it. Whenever you go to do an electrical connection, pierce it and force the cable through. You don't damage the grommets. Here we have the flow sensor. So whenever you're using these plastics, always keep them clean and put some silicone on. With these, I do recommend a mini shock arrest. Look how thin that plastic is. Vaillant and Glowworm, good boilers. So there's a flow sensor. So if you get no hot water, it could be this component. No hot water, that could be the fault. No hot water. So look at the interface. Is there some form of tap symbol or anything on the interface that tells you there's demand? Next thing, go to the Vaillant or Glowworm interface and look for D22. If that's spinning, if that's working, D22 will say on. So that's spinning and saying it's on. D22, hot water demand, is on. No further. What you could do is though, you could go to D36 and that'll tell you liters per minute. So basically that will tell you how good that is spinning. If there's any jams or blockages. If you want to go further, to get more technical, DC voltage, direct current. So that's the line symbol. So you go from black to green. If it's working in demand, 2.5. From black to red, you should get 4.7. This mechanism is called the Hall sensor. So when that spins round, the magnet inside creates conductivity and joins those 2 points together. If you want to improve your heating system, flow rate and performance, underneath this diverter valve is a bypass. So you can adjust that to increase your flow rate and your system pressure. If you want, you can close it and open it up slightly. So here we have the diverter valve, and there's the motor. So the back left and back right, you should have a resistance of 150. The front left and the front right, you should have a resistance of 150. And on these diverter valves, it says at the front 150 resistance. I want to talk about that. If your system's dirty, it will leak through the shaft. That's if your system's dirty. You can actually dismantle these, take them apart and clean them. So, if you have no heating or no hot water, it could be the diverter valve stuck. And if you want to know if it moves, turn the boiler on and off. Off and on a few times, and you'll hear or see the diverter valve move. Next thing, go to the interface and go to D35, and that will tell you the position of the diverter valve. If it is a Vaillant, you can put it in a test mode and you can move the diverter valve to whatever position you wish. Here we go. So here we are, front left, front right, resistance, which is the Horseshoe, 200k Horseshoe, and it was reading 150. Front left, front right, 141. So it's on the Horseshoe, below 200, and it's plus or minus 10%. So it had to be within 135 and 165. These are NTCs. These measure the flow and return temperatures. If you think they're faulty, move them. The pin inside will reconnect with the surface. So now I'm going to check the readings, the resistance readings for this NTC. So I've moved it an inch to see if it will reconnect on the surface. I've removed the wire harnesses. So we're doing the test actually on the NTC thermistor. It's on ohms. I've set it to 20k. So here we go. 15,000 ohms, that's right. It is about 15 degrees in here. So this is a negative thermistor. So basically what that means is, should this fail, the resistance will lower. So for example, if this was breaking down, the resistance, instead of being in the thousands, it could be in the hundreds. So therefore, it wouldn't send any signal back to the boiler, the PCB, to fire up. If your hot water is fluctuating in temperature, this could be blocked. Isolate the hot and cold water supply, the heating, flow and return, drain down and take this out. Always check these O-rings are clean before you put this back. Because there's a lot of plastic in this, I would recommend fitting a shock arrestor and a descaler on the cold feed. So it absorbs the pressure and the expansion in water supply and not put pressure on the composites. Here's the plate to plate. If you're getting fluctuating hot and cold water, put vinegar and boiling water inside these channels, give it a tap, shake it around, drain it out. Blast cold water through it because that causes a thermal shock. Vinegar, boiling water again on both sides, tap it, knock it, shake it, then cold water. Keep doing that and that should get it going again. Plate to plates are made of two different metals. The reason why that is, they expand at different rates. So they expand moving, and that will knock any scale off. In this section of pipe here, you'll see a canoe filter. Take it out and wash it. Turn it a couple of times, and inside you will see a filter. Here we have a gas valve. It's a 24-volt gas valve and it's only got one solenoid on it. So if you think this gas valve is faulty, isolate the gas underneath, do a tightness test and leave it there. So put your U-gauge on, isolate the gas, do it to say 20 or 80 millibar, put demand on. If it loses pressure, that tells you the gas valve is opening up, but it's not igniting. It could be sticking. Sometimes if you give it a tap or put a hairdryer on the base, it might free it up. Inside the gas valve on the entry inlet is a filter. Check that's not got mist or dust particles in it. The next thing you can do is a resistance reading. To do a resistance reading, turn the power supply off, remove the harness. So you're doing a resistance reading on the component. Go to your multimeter and select resistance or ohms, which is the Horseshoe. Go to 200. This is just a cheap multimeter, but it does the job. 200, and you should be getting 41 to 45 ohms. Plus or take 10% either side. That's your allowance. The gas valve is 24 volt DC. So DC is a straight line. AC is a wavy line. No ignition. So you've checked the gas valve. It's letting gas through, but it's not igniting. First of all, check the electrodes. Check the gap. Check there's no dirt or scale build-up on the electrodes. Check the earth. Check the cables connected to the earth properly. Next thing is to check the HT lead. That's the black cable. So isolate the power supply. Make sure the power supply has a 3 amp fuse in. If you think the PCB is faulty, you can always put a hairdryer on it briefly and that'll warm it up and reactivate it. So the HT lead, you can check that using a multimeter. I've set the multimeter to ohms, which is the Horseshoe, 2K, nearest as possible. Disconnected it. I've got one probe on the ignition side, one on the PCB side, and you need 1k ohm. And again, 10% allowance. So 1k ohm. Fault F75. You might think it's the pump. It's this. It's a pressure sensor. Drain the flow and return, undo the clip and pull it out. These do often need replacing. I'll show you now how to test it and how to temporarily fix it. So So let's talk about the pressure sensor. So the pressure sensor, this is what it is. So for this, if it goes faulty, you'll have no heating, no hot water. The fault will be F75. So basically when the pump comes on, this will increase the pressure by 0.2 bar. So a fault code might be low pressure or faulty pump, but check this first. So first things first, tap, clean, vinegar. So put some vinegar in the top, give it a tap, and you'll get some rust and magnetite out. That might free it up. If this keeps blocking, the system needs flushing. But really, cleaning it, if it doesn't work, replace. How these work, there's a magnet. When the pressure increases, this diaphragm moves, and so does the magnet. To test this is 5 volt DC, which is a straight line multimeter. So from black to red, you're going to get 5 volts. And at 1 bar, you should get about 1.7 volts DC. Pressure sensor. These pumps are really good, the Gunfoss. If your heating system's struggling, or before you turn the appliance on, here is an anti-seize screw. Put a screwdriver in it, and just turn it through the impeller up. If you're getting fault codes between F0 and F21, it could be the pump seizing, and the temperature difference between the flow and return is too low or too great. If it's a big system, go to decode, go to D14 and select maximum, which is D14.5. Here we have the automatic air vent. These are there for a reason, so always make sure they are open. For some reason, some installers turn them off, leave them open. So any air that comes to the boiler appliance will be released here. These will leak from time to time, so there might be traces of leakage. That's nothing to worry about. If it's constantly these are automatic air vents. They release the air to prevent it going to the heat exchanger. You might see signs of leakage. There's nothing to worry about. If it does continue to leak, I will show you how to take it out. Always make sure it's open. For some reason, installers turn them off. They're there for a purpose. So make sure the flow and return are turned off, drained down as described earlier. Take the clip out, and then you can pull it out. Like so. If it's an emergency, try giving this a wash. These can seize. Try giving it a wash, and you might be able to temporarily restore it or seal it. Use silicone spray. Put the clip back. Downfiring fan, silicone heat exchanger, silicone so it can't get corroded or pinhole. The silicone is actually pre-made into the mix here. It's four-sided cooling, so as the water goes round in the heat exchanger, it moves the water molecules and creates turbulence, so it heats all the molecules up. You slightly undo the 2 rear nuts and remove the front 2, and the heat exchanger comes out. Take it out every 5 years, give it a clean. Cat C gas valve, so it uses the fan to lift up the second solenoid. Yeah, so let's talk about the interface. So this next clip was taken on a Warriors of Warmth charity install. It was carried out for free on behalf of the RSPCA. Press the top 2 buttons. S modes. So that's live monitor, and that is sequence of operation. If you ever have any problems with the glowworm or Vaillant boiler, that is what you want to go to. The S codes. They are absolutely superb. That'll tell you what it's doing, what it's thinking. So here, code. I'm going to put 17, enter. D codes, here we go. The range rating is vital because it tells the boiler how many kilowatts to produce, and it makes it a lot more efficient. So rather than going high fire, when it goes to ignite, it might modulate cleaner, quieter. But if you range rate a boiler, it'll respond quicker. So you've got a range rate. D8, that'll tell you if the controls are working. It's for 240 volt controls if it's getting a return back. D10, that'll tell you if the pump's working. D14 is the pump, how fast or modulating if you want the pump. My favourite coming up. D22 is the hot water. Turn the hot water tap on, that'll tell you if there's hot water demand there. D33, brilliant. That's the fan. D34, that's the fan. We'll talk about that in a moment later on. So D33, D34. So on all fans, on the propeller, there's a magnet and there's a tachometer on the PCB in the fan, and it measures the actual speed. But the boiler knows what the desired speed is. So D33, D34, it tells you what the desired propeller speed is, and it tells you what the target is. Those two figures should be within 200 revolutions per minute. If they're not, the fan's getting a little bit slow. D35, that's the position of the diverter valve. So that'll tell you if it's in heating or hot water mode. D36, litres per minute, so that'll tell you if the aqua sensor is working. D40, D41, that's the flow and return temperatures. D84, that's a good one. That's service hours. So you can put in 2,400 hours. D88, what a great one. D88. So if you've got maybe a big water main and there's back pressure, what that can sometimes do is it can shudder the aqua sensor or the water turbine and make it fire up. So D88, it allows several litres of water to pass before the hot water fires up. Come out of that. So whenever you fit the boiler, always cement round. Screw in the flue elbows, because gas safe do look for that in an inspection. What I'd recommend for these boilers is always get some fixed head spanners, so it makes it a lot easier fitting it up. And usually with these boilers, tip it upside down, make the connections first, tighten them up with a fixed head spanner, and then you're good to go. These grommets, just pierce them, don't cut them open. Yeah, cracking boilers, great service, great employers, great backup.